Okay, so in this video, I'm going to walk you through calculating the t-value, the t-statistic. And again, I'm going to use the same data that we've been talking about on the past couple of videos, where we're talking about mice that have been either exposed to penicillin or not, and the amount of bacteria in their fecal samples. And so to find the t-statistic, I'm going to use this formula right here. And again, this is found right in the packet that you got in the lab. You're asked to calculate this on page 5, but the actual formula is found on page 2. Okay, so let's look at this formula. So this formula, I struggled a little bit with getting it to come out properly in this form, but it's pretty much all here. So to get the t-statistic, and let me actually put t equals here. So t equals. So what we're going to do is we're going to take the absolute value of the mean of our A group, so our control group, minus the mean of our B group, so our penicillin experimental group. And so that will be the absolute value of 8 let's just do this, so the mean here. So 8.616 minus 4.58. And what you should get as an answer, let me just plug those numbers in. So insert symbol. So I'm just going to insert the symbol for absolute value. And it's going to do 8.616 minus 4.458. And I'm going to end it with our absolute value. Okay, so that's the top of my equation here. And when we do that math, the answer there comes out to 4.158. Hopefully I did that math right. And the bottom part of this equation is a little bit trickier. So we have to do the square root of our variance for group A minus the variance of group B divided by our sample number. And so remember, n is equal to 5 because we have 5 in each group. So we know n. SA, so that will be the variance of our control group. So that's going to be 0. We'll round up 802. That's going to be a minus sign on that. That should be a plus. I wrote that wrong. Yeah, let me change that really quick on here. Thought I put plus sign. That work? Yeah, kind of. It's hard to see. So it's going to be a plus on the bottom there. So it's going to be our variance for our group A, which is our control group, plus the variance of group B, which is 0.995. Okay, and then we have to divide that by, so actually let me do it. Oops. So we'll do our parentheses here. So make sure we do that first. And then we're going to divide that by our n value, which is 5. Okay. So I will add these two together and divide by 5, and you should get the answer of 0.379. Okay, so our numerator is 4.158. Our denominator, we calculated to be 0.379. And so our answer, our t-value, when we divide 4.158 by 0.395, that's going to give us our t-value, which should be equal to 6.936. Okay, so that's our t-statistic. So now what do we do with that? So again, hopefully you read the beginning of this packet where we talk about degrees of freedom and what this t-value means. So let's figure out what our degrees of freedom are first. So I'm going to represent this by df. And so to calculate degrees of freedom, again, if you kind of look back in your packet, we tell you that the degrees of freedom is equal to the sample number, so n, of group A, plus the sample number, n, of group B, minus 2. Okay, so that's going to be 5 plus 5 minus 2. So our degrees of freedom, which again is df, is going to be equal to 8. Okay, so now what do you do with that number? And so I don't have this table on here for us, so you got to look back in your packet with me. On page 2, you'll see table 1. And table 1 gives you critical values of the t-statistic. And so what you're going to do is you're going to find your degree of freedom, which we just said was 8. So you're going to go down in that table to 8 and go over to get your t-critical value. And so if my degree of freedom is 8, my t-critical is going to be equal to 2.306. Okay, so again, how did I get that? Just looked at the table on page 2. I looked up my degree of freedom, which is 8 in the left-hand column, and I went over, and that number there is 2.306. Okay, so what does that mean? So if we go down to table 2, again on page 2, it says interpreting the results of a t-test. So our t-value we said was 6.936. Okay, the t-critical value is 2.306. So we're comparing those two numbers. So it says if your t-value is greater than the t-critical value, which in this case ours is, right? So 6.936 is greater than 2.306. So if that's the case, it says that based on this data, you should reject your null hypothesis that treatments have the same effect. Therefore, this provides statistically significant evidence to support rejecting the null and supporting the alternative hypothesis. Okay? If your if your t-value was less than or equal to your t-critical value, which it's not in this case, but let's say it was, then that would not support rejecting the null hypothesis. And therefore, you would say that the difference between our two groups are not statistically significant. And so in this case, it would be the use of penicillin does not alter the number of bacteria in fecal samples. Okay? But again, since our t-value was greater than the t-critical value, we would say that the null hypothesis in this case is not supported and that there is a statistically significant difference in the number of bacteria in fecal samples from these two groups of mice. Okay, so that's how you do it by hand. Let me show you the shortcut. So Excel will do all of this for us. The one thing that you have to have, I'm going to come up here to my top ribbon here, and I'm going to click the button that says data. And so the one thing that you have to have is this thing called the Data Analysis Tool Pack. And if you don't have it, I do have directions on how to get that. It's a free add-on, okay? So if you need to do that first. Again, look at the directions to do that. So I'm going to click on the Data Analysis Tool Pack, and a list of analysis tools are going to come up. It's a long list. And the one that we're going to use right now, we're going to use a couple of different ones throughout the semester, but the one that we're going to use right now is going to be called the t-test, and you'll notice there's a couple of different types of t-tests. We're going to select the t-test where it says to sample, because we have two samples, a control and an experimental, and it says assuming unequal variances. And so if you look at your variances, they're not equal. So it makes sense what we're choosing. Okay, and so you're going to highlight that, and you're going to click OK. And then this little dialog box is going to open up. And so in this dialog box, you are going to select your data. And actually, mine is already selected, but I'll show you how to do this. So let me just bring this back down. Okay, so what you're going to do first is you're going to select the variable range number 1. And so you're going to select the data for your first group. And so I'm going to click here on the up arrow, and I'm going to select my data. And so I'm going to select from B2 to B6. Okay. And so I'm actually, what I'll do is I'll actually select the label here at the top too. So from B1 to B6. Okay. And then I'm going to select my second input, which is my penicillin group. So this is already selected. Okay, I'm not selecting the totals. I don't need the sum. I just need the data, the individual data. Okay, now since I decided to select the top labels of each column, so the control and the penicillin I included in there, I need to make sure that I have this little box checked here to tell Excel that I included my headings, my labels. Alpha should be preset to 0.05. And then down here for output range, it may, whoopsie daisy, I didn't want to do that. It may select a new page. I didn't like that anyways. So this might be pre-selected. What I would say is don't select that. Instead select the first one, which says output range. And then next to that, you have to tell it, where do you want this data? I don't want it on a new sheet. I want it on this sheet so I can see everything in one space. And so I'm going to collect this box, click this box next to it to tell it where I want the data. And so I'm going to actually move it. I'm going to put it over here. Okay, so I'm telling it I just want it in this space. I'll click this little box again, and everything else looks good. So I'm going to hit OK. And it's going to spit out this table. And I want to make sure that I can see the whole table. And so, again, here's my original data. My graph is up here that I made in the previous video. And here is my t-test data. So what's on here? So again, it tells you that this is a t-test. It's a 2-sample assuming unequal variances. So I have 2 samples, control and experimental, and my variances are not equal. So that's the one I'm going to select. I put the headings, so it gives me these nice headings here. I like to include those labels. So I have my control and my penicillin. It tells me the mean, the variance, so I can double check all those numbers. It tells me my N, my sample size. So I have 5 for control, 5 for penicillin. It also gives me my degree of freedom, which we calculated by hand. It's 8. And it gives me my t-statistic, which again, we calculated by hand, right? My answer was up here, and it is the same, 6.936. They took it out farther in numbers. What we have is fine. What else do I want you to look at on here? So we are going to look at this data right here, the data from the two-tail t-test. And we will look at this right here, the t-critical two-tail. And so what is this? Okay, so first off, our t-statistic, which is right here, 6.936, is the same as our calculated t-statistic. The critical value, t-critical here, 2.306, is the same thing we looked up in our table. And so again, just based on those two numbers, we can formulate our conclusion, right? We know that, right, from page 2 of that packet, that if our t-statistic is greater than our t-critical, which it is here, then we reject our null hypothesis, and there is a difference, a statistically significant difference in our two groups. Okay? There is one other number I want to point out on here before we end this video, and this is a number that we're going to use in the future. So I just want to make sure that you're aware of it. And so right here, again, we did a two-tail t-test. Don't worry about the one tail. I want you to look at the p-value. Okay, so that's another value that's going to come into play when we go on in statistics. So our p-value for this particular set of data is 0.00012. It's a very small p-value. The smaller the p-value, the more statistically significant your data is, the more confidence you can have in your data. So if your P, here's the cutoff, if your P is less than 0.05, then you would say that there is a statistically significant difference in these two groups, okay, which is true here. If your p-value is greater than 0.05, then you would not reject your null hypothesis. You would say that the data does not show a statistically significant difference. And the differences that we do see are just due to chance. Okay? So again, in the future, we're really going to be using this p-value. Okay, so hopefully you can use Excel to give you this data, this statistical data. And again, we will do it by hand just this first couple of times just to get the hang of the math and to understand the math behind it. But we have this wonderful tool in Excel that makes our lives much easier. And so after these first couple of experiments, we'll go on and we'll just use Excel. And we'll actually be using some other types of t-tests that later in the semester I'll be telling you about. Okay.